Have you ever wondered how a brand new life-saving medicine actually makes it from a science lab to your local pharmacy? Well, the secret isn't just about chemistry, it's about a hidden language, the language of data. And today, we are going to decode that language. We're talking about biostatistics, the incredible tool that turns a bunch of numbers into discoveries that can save lives. All right, so let's just kick things off with a huge question. Imagine a company says they've created a new drug that's going to change everything. They've got piles and piles of test results, patient charts, all sorts of numbers. It looks good, sure, but how do we get from them just claiming it works to us actually knowing it works? How do we prove it? Well, the answer is all about taking that messy, chaotic, raw information and transforming it into something clear, something powerful. And that is the whole point of biostatistics, finding the signal in all that noise. So here's our game plan. First, we'll talk about what data in medicine even is. Then, how we organize the numbers, how we find a typical value, how we measure the data spread, and finally, how we can spot relationships hiding in the data. Okay, first up, data in medicine. Let's start with the absolute basics. What exactly is biostatistics? At its core, biostatistics is really just applying the tools of statistics to the world of biology and health. You can think of it as the crucial bridge that connects all that raw data to actual life-saving medical insights. And why should you care? Well, think about it. How do we even know what a normal blood pressure is? Biostatistics. How do we prove a new drug is safe and effective? Biostatistics. How do we know a vaccine works? You guessed it. It helps us track down the causes of disease. I mean, it is literally the engine that drives modern public health. All right, section 2, organizing the numbers. So now that you have all this data, the very first step is to create some order out of all that chaos. And our number one tool for that is something called a frequency distribution. Now, it sounds a little fancy, but the idea is wonderfully simple. It just shows you how often or how frequently each value shows up in your data. Let's take a look at this super simple example of tracking who drank tea. When you just have a list, it's a jumbled mess, right? But the second you organize it into a frequency table, boom! A pattern just jumps right out. You can instantly see Akash had tea 5 times, Just had 4, and Pradeep had 2. It's so simple, but so powerful. Now, tables are great, don't get me wrong, but you know what they say, a picture is worth 1,000 words. And that's where graphs come in. And here are 2 of the heavy hitters. On the left, we've got a histogram. This is what you use for continuous data, like a whole range of student test scores. See how the bars are all touching each other? Then on the right, you have a bar graph. This is perfect for comparing separate categories, like the number of students in different classes. That little gap between the bars is actually really important. Okay, let's move on to section 3, finding the typical value. So our data is all organized and looking good. The next thing we want to do is find a single number that can kind of represent the whole group. We're going on a hunt for the center. In the world of statistics, these numbers are called measures of central tendency. I like to think of them as 3 different detectives, and each one has its own unique way of finding that typical value. You've definitely heard of them before: the mean, the median, and the mode. First up is the one we all learned back in school, the mean, or as you probably call it, the average. You just add up all the values in your set and then divide by how many values you added. It's the most common way to find the center, for sure. For example, look at these 10 numbers. We add them all up, which gives us a total of 30. And since there are 10 numbers, we divide by 10. Our mean is 3. Simple as that. Next up is the median. The word to remember here is middle. But, and this is a big but, you have to arrange your data in order first, from smallest to largest. The median is the value that's physically in the dead center of your list. This example makes it really obvious. We've got 5 different student heights. We just line them up in order, and the one right in the middle, the third value, is 168 centimeters. That's it. That's our median. And our third and final detective is the mode. The mode is all about popularity. It's just the value that shows up more often than any other one. Which number is the most common? That's your mode. So in this set of tablet weights, all we have to do is scan the list. And you can see that the number 122 milligrams appears 4 times. That's more than any other number, so 122 is the mode. So which one do you use? This little table is a fantastic cheat sheet. The mean is your best friend when your data is pretty symmetrical and doesn't have any crazy extreme numbers. But if you do have some extreme values, we call those outliers, the median is your hero because it won't be affected by them. And the mode is perfect for finding the most popular option or for data that isn't even made of numbers.
On to Section 4, measuring the data spread. You see, knowing the center of your data is great, but it doesn't tell you the whole story. You could have two groups with the exact same average, but they could look completely different. To understand why, we need to measure their spread.
This idea of spread is called dispersion. It basically tells us if our data points are all clustered tightly together or if they're scattered all over the place. And the absolute simplest way to measure this is with the range. It really doesn't get more straightforward than this. You just find the highest value and subtract the lowest value. For this patient data, the highest is 13.2 and the lowest is 8.3, so the range is 4.9. In an instant, we have a good measure of how spread out this data is. And that brings us to our final section, seeing the relationship. So we've organized our data, we've found its center, we've measured its spread. Now for the final piece of the puzzle, finding out if there are connections between different sets of data.
This is where correlation comes into play. Now, this is really, really important to remember. Correlation does not mean one thing causes another. It's not causation, but it is a super powerful tool for seeing if two things seem to be related, if they tend to move together. And correlation can go in two directions. A positive correlation means that as one thing goes up, the other thing tends to go up too. Think about height and weight. Then there's negative correlation. That's the opposite. As one thing goes up, the other tends to go down. A good example is the amount you exercise versus your risk for heart disease. And so that's the whole journey in a nutshell. We start with this messy pile of raw data, but by using just a few of these fundamental tools, from frequency tables all the way to correlation, we can turn that chaos into clarity. We can uncover the incredible stories that are hidden deep inside the numbers. Look, these tools aren't just some abstract math concepts. They are the actual building blocks of medical discovery. They're used every single day to test new drugs, to understand diseases, and to save lives. They give us the power to make sense of the world around us. So the only question left is, what story will you uncover next?